Hello, everybody. All right, welcome to our first post-quiz lesson. We'll start with a quick review of the items that we did on the quiz yesterday, just to get your mind in there, and then we're going to shift into some new topics. All right, so I am going to look at this equation right up here. I'm going to find the y-intercept. I'm going to find the axis of symmetry, vertex, max, min, x-intercepts, domain, and range, and we're going to graph this just to get our mindset back into some of the things that we've been learning about. All right, easy. You know this one right away. The y-intercept, I just looked directly at that last number there. My y-intercept here is going to be -3. Why don't I just come on over here, and on the y-axis, I'm going to plot -3. All right, axis of symmetry. You know this. -b over 2 times a, and it'll always be x equals. So x equals -2, so just a +2, over 2 times a. Well, there's nothing there, so it must just be a 1. 2 times a 1 is 2, so x is equal to 1. There's our axis of symmetry. I'll grab my highlighter and let's draw that. Ooh, there we go. Notability saved me again. All right, vertex. We find the vertex now that we know x is equal to 1. I'm just going to go ahead and plug that 1 into the equation. So 1 squared minus 2 times 1, replacing all the x's from my equation with that 1, minus 3. And so y must be equal to 1 minus 2 minus 3. Y is equal to -4. All right, so my vertex will be at 1. My y is -4, so over 1, down -4. Not surprisingly, it lands right on that axis of symmetry. Now, before I even do another thing, I know I've got another point right here. Looking at that axis of symmetry, I know that's just like a mirror. I can find the point directly on the other side. All right, this thing, here is the vertex. Looks like it is going up at least here and here, so I will definitely have a minimum, not a maximum. And since I already know my vertex is where this thing turns around, that minimum value, the lowest it's ever going to get, is right there. So that is -4. All right, x-intercepts. Remember, with x-intercepts, we need to use our x, -2 in the bottom, -3 on top. -3 is 1 and 3 or 3 and 1. Not too many options there. If I want to get to a -2, -3 times +1. Product is -3. Sum is -2. So I get x minus 3, x plus 1. Find the zeros. X equals 3. X equals -1. So I can come right up here to the graph. They're going to hit at x is 3 and hit again at x is equal to -1. Both of them are 2 spots off of my axis of symmetry, so I know I got them right. Okay, so -1 and 3. All right, so let's just connect these. I've got my 5 points that I need. Domain, what are the x values I can have? I can have them all. No matter what, I can pick any x value. Range, though, those are my y values. I'm not going to get all my y values. Remember how I pointed out that the minimum right here is at -4. I'm not going to get anything lower than the -4. So my y values must be greater than or equal to -4. All right. You knew that stuff, but I wanted to get you back into the mindset. So let's look at some new stuff. All right, we are going to look at these 3 different graphs, I apologize. The blue one, y equals x squared, just a very normal, boring parabola, right? Just our standard parabola. And it's asking us here, where is the vertex of this? Okay, well, the vertex is right here. That's just right there at 0, 0. All right, well, here is one that looks a little more interesting. X plus 2 squared. The 2 is inside the parentheses. Let's look at our graph here. Looks like we went left 2, so -2, but we didn't go up any. We're still on the x-axis, so our vertex there is -2, 0. And on the red example here, I didn't move left or right, but I did go straight down 1, 2, 3. So here I am. My vertex there is 0, -3. So let's just take a moment, pause, take a look at those and see if you are starting to notice any sort of pattern. All right. Well, I don't think I have enough to go on just yet, but I am noticing there's a 2 there and there's a 2 there. There's a 3 there and there's a 3 there. There's nothing here other than the X, and those are both zeros, so maybe that has something to do with it. Let's take a look at a few more before we move on. So here, okay, this one is flipped upside down. Okay, well, I've got a negative sign there, so that's interesting. But again, my vertex here is at 0, 0. All right, this one, up 1, 2, 3, 4. Okay, this one's at 0, 4. And I've got another 4 there. All right, here this one's got a 1 in it. And yeah, my vertex, I went over 1, up 0. So these both have a 1 in them. All right, okay, now I've got 2 numbers. Now I've got a 4 and a 1, or here I've got a 1 and a negative 2. So here I'm looking at my graph. I went over 1, 2, 3, 4. So I went 4 to the right and up 1. And here I went 1 to the left. So I went negative 1, negative 2. And I'm just grabbing the points right here. I'm just looking at the point and giving the coordinate. So if we start to notice some things on here, one is the negative sign, right? And I think we've even seen this before. That negative sign we can see when we have a negative in front, that's going to flip our graph upside down. I definitely see that. Here's what else I want you to notice. All right. When I don't have anything, we're at 0, 0. When there's no other numbers. When I have a number inside the parentheses, so let's look at this one. When I have a number inside the parentheses, it seems to change the X value. When I have a number inside the parentheses, it changes the X value. When I have a number where there's no parentheses, like here with this 4, it seems to change the Y value. And even further, one thing you might notice is that the X part of it, ooh, that's a bad color for this. The X part of it seems to move in the opposite direction. And the Y part of it moves in the same direction as you might think. So X minus 4 inside the parentheses, that moved this thing 4 to the right. X plus 1 in the parentheses actually moved it 1 backwards. But plus 1 on the outside moved it up 1. Minus 2 over here on the outside moved it down 2. So we're starting to get an idea of how these things are going to move. And at this point, I'm sure there's at least a few of you who are saying, wait a minute, I've seen this before. This seems familiar. And now you're thinking, whoa, did Mr. Aslan just read my mind? And now, wait a minute, am I in the Matrix? All right, don't worry about it. Let's get back to the math. All right, so yes, you absolutely have seen this before. You saw it earlier in the year with Mr. Obama when you all were talking about absolute value functions. Remember the absolute value function always looked like V's, right? They came down and it's like they bounced directly off like a pool ball or a basketball that you're bouncing on the ground. Those moved in the same way. And if you remember correctly, I've got my blue highlighter here, just the regular old one, right? X, Y equals the absolute value of X. That came down and hit exactly at the origin, right? But when I put a number on the inside, X plus 3 on the inside of the absolute, it made this one, the purple one here, it made it move 3 to the left. It moved in the opposite direction that you would think. And when we put a number on the outside, absolute value of X, minus 2 after that, that made it move up and down. Right here, it moved down 2 just as you would expect. So again, you have seen this before. So just kind of access that part of your brain and we'll take off of that, right? Inside the parentheses, we're talking about left and right. Outside the parentheses, we're talking up and down. And don't forget, if we threw a negative in front of any of these, it would flip it over. Okay, this leads us right into what we call our parent function. Okay, parent function means just the normal one. And we looked at this right away in our first example. Our parent function, the normal one, is always going to have its origin at 0, 0. Why? Well, because we didn't have anything inside the parentheses with it, and we didn't have anything outside the parentheses. They were both zeros. That's why we didn't write anything over here. 0, 0. The domain on these things, always going to be all reals. That's a nice easy point on any test I give you. Range, okay? On the parent function, we get all the positive numbers, right? For y, we get all the positives. We don't need to worry about any negatives. Why? Well, you guys know this. If we're talking about something squared, it's never going to be negative, right? Every time we square a number, it turns into a positive number. 2 squared is 4. Negative 2 squared is also 4, because negative 2 times negative 2. So that's why we're only dealing in positives with our normal function. Now, if we move it up or down, we may get some negatives, but this is what our standard range is going to look like. Okay, well, that's easy enough. Well, let me then give you. All right, we have been dealing with factoring, all that sort of stuff. We've been talking only about standard form. The new form I want you guys to start looking at here, actually, let's make this a little bit wider for me, is called vertex form. And the handy part about vertex form is that it's going to give you the vertex right in there. So remember, if it's inside the parentheses, that's moving it left or right, right? So that's our x value. And it's always going to be the opposite of what we think. Here it was minus h, so it's going to be regular h right there. If it had been plus h right here, we would have had a negative h, right? So we always just look at the value there and take it the opposite. All right, this one moves it up and down, right? The one outside the parentheses moves it up and down. That's our y value, and it always moves in the exact same direction as we would have thought. So if I give you a nice easy one like this, you say, okay, inside the parentheses, that is left and right. Outside the parentheses is up and down. Okay, this is going left and right, and this one always goes with the opposite of what I think. So I think that instead of going -7, this thing is going to move 7 to the right, and you'd be correct. This one outside the parentheses is going to move just like you think. We'll say that it's going to move the regular way. +1, that means our vertex is going to go up 1. So this form, as you can see, is going to make it really easy for you to find the vertex, which in this example is at 7, 1. Okay, there you go. Left moves it up or down. H moves it left or right. K moves it up or down. The A, the only thing we're seeing here today, we'll talk more about A tomorrow, but that is going to, if it's negative, it flips the whole thing so it opens down. But if A is positive, it's going to be our regular upward facing parabola. So let's try a few examples before I get you to the assignment. I think you're going to find this to be nice and easy. All right, A, what's going on? T means what is the transformation? What is going on with the graph? How is it changing from the parent function? All right, well, I've got a number inside the parentheses, so I know that's my right or left number. And inside, I'm going to do the opposite. So this is going to go right 1. Okay, so where's my vertex at? Well, I went right 1, so it's at 1. I didn't move up or down, so it's going to be at 0, just like it shows in my graph here. Domain, nice, easy, it's all reals. Range, notice something. Okay, range, the lowest value it's ever going to be is 0, and range relates to y. All right, do I get the numbers that are above 0 or below 0? Well, above. So I get y is greater than or equal to 0, and notice that 0 just followed me down there. All right, second example. X with the -3 outside of the parentheses. All right, outside of the parentheses is the up and down part, and it moves just like I would expect. So this one is going to move down 3. All right, my vertex. It didn't move left or right, so I'm going to stay right there with my X. But since I moved down 3, my vertex is at 0, -3, which shows up right there in my graph. Domain, here's my easy point, all reals. Y values, okay, Y, the minimum again is this -3. It doesn't get any lower than that. Faces upward, so Y is greater than or equal to -3. That's as low as I'm going to ever get, but I get all the Y's that are greater than that. If I pick any random Y above this, I can find a point where I'm going to hit that Y. Okay, and again, it just followed me down. All right, last one. Okay, now I've got things inside the parentheses, and I've got some outside the parentheses. All right, inside the parentheses, that's left or right, opposite of what I think. So since it's negative, it's going right. All right, so I go right 4. Outside the parentheses, up and down, it moves just like I would expect, up 1. So my vertex, right 4 means I'm at 4, up 1 means I'm at 1. So over 1, 2, 3, 4, up 1, that's exactly where I find my vertex. Domain, easy points is all reals. Range, Y, I know now I'm just going to grab this point, and are the Y's I get bigger than 1 or are they smaller than 1? They're going to be greater than or equal to 1, right? Because I'm getting the Y's that are bigger than that. All right, a couple more examples. One more with the graph, just so you can see what it looks like when this thing is flipped, and then a few without it, because we don't need it at this point. We're good. Okay, this one got flipped over. Why did it get flipped over? Well, that negative sign right there in front. That -a made it flip over. Okay, so I said my transformation. One is flipped. Inside the parentheses is left and right. Opposite of what I think, so that is +1. So this thing must move left 1. And outside the parentheses, -2. That's my up or down, and it moves as I would think, so down 2. So where did my vertex go? It went left 1, so that's -1, and down 2, that's -2. That is exactly where I found that point. All right, domain, easy points, all reals. Range, I know I need Y. I know I'm just going to snag the number -2 from right there. But now, which Y's do I get? The ones that are above -2 or the ones that are below -2? Now that this is a maximum, the highest it's going to get to, I'm going to get Y is less than or equal to -2. All right, let's just take a quick look at these three without a graph. All right, inside the parentheses, -5, that's my left or right. It moves opposite of what I would think. So since -5, that goes right 5. -7 on the outside, that's my up or down. It moves as I would think, so down 7. My vertex is at 5, -7. All right, here I've got nothing inside the parentheses, but I do have a 6 outside. So this thing is going to move up 6. So my vertex, I didn't move left or right, so that's still going to be 0. But when I moved up 6, my Y turned into a 6. Ooh, here we go. I'm going to flip. So my first transformation that I notice is going to be flipped. Then my second, I'm inside the parentheses, so that's my left or right. Opposite of what I would think. Well, negative numbers are usually left, so this must be going right. And it's going to go right 9. So my vertex, I'm going to move right 9, but I'm not going up or down, so that'll stay 0. All right, I think we went through that pretty quickly, but I think you guys got this, especially because I know this is something you talked about in regard to absolute value functions. So it's just a matter of reconnecting those synapses and giving them a little different view on this. I obviously will have office hours, so if you have questions, I can feel free to answer them then. Also, feel free to email me or send me a Schoology message, and have a great day. This can be found